Hello, everybody. So we're going to continue with sixth grade module 13, lesson 13.2, area of triangles. And basically, you need to be able to explain at the end of the lesson, how do we find the area of a triangle? So in the explore activity today, you're going to draw and label a large rectangle on grid table. Sorry. Draw and label a large rectangle on grid paper as shown. Okay, so we have this large rectangle, right? And so what is the formula for the area of a rectangle? Well, we know that that's base times height or length times width. Okay, they're equal. Okay, then after you've drawn your large rectangle, draw a diagonal through it. And what does the diagonal divide the rectangle into? Okay, look at the top section and the bottom section. We have two right triangles. Okay, here's a right triangle and here's a right triangle. Each triangle's area is going to be half of the rectangle's area. Okay, so if we have like this bottom section here, this area is going to match this area, but it's half of the whole rectangle. Okay, so keep that in mind and write a formula for the area of a right triangle. Well, so the area of the right triangle is 1/2 the area of the rectangle, right? Well, what's the formula for the rectangle? Base times height. So a triangle is simply 1/2 the base times its height. All right, so in the formula for the area of a right triangle, what do B and H represent? They represent the length of the sides that form the right triangle. Okay, so what are the two sides that form the right angle? Well, that's right here, right? So the base, that's the length of the base, is one side, and the height is the other side that form the right angle of the right triangle. All right, so now activity 2. Draw a large triangle on grid paper, but do not draw a right triangle. Okay, so something like this. All right. So this is a large one I drew. Okay. All right, and then you're going to cut the triangle out. Okay. And then you're going to trace it around it to make a copy of your triangle and cut out the copy. Okay, then once you've cut out one of the triangles, cut one of the triangles into two pieces. Okay, so I took mine and I just cut it in half. Sorry, I have to get it oriented correctly. All right, so just cut it in half. So we have one large triangle, the large triangle, and we have two smaller triangles. Okay, so now we have three triangles. Okay. Now let's go on page 380 and see what we're going to do with those three triangles. Okay, when added together, the areas of the two smaller triangles, the two smaller triangles, equal the area of the large one, right? So now we can take the three triangles and arrange them into a rectangle. What fraction of the rectangle does the large triangle represent? So let's put the large triangle. And then let's put the other two triangles to form a rectangle. Okay, so we took the two smaller pieces, put them to the sides, and we form a rectangle. Okay, so what fraction of the rectangle does the large rectangle represent? Again, we have three pieces, but these two matched the area of the large one, right? So we have this large one is half the area of the large triangle of the large. The large triangle is one half the area of the rectangle because these two pieces represent the copy of the triangle that we cut into two pieces. So the area of a rectangle is area equals base times height. What is the area of the large triangle? Well, it's the same that we've already done, right? One half the base times the height. How does this formula compare to the formula of the area of the right triangle you found in Explore Activity 1? They're the same. Okay. 2. What type of angle is formed by the base of a triangle and the segment you measure to find the height? So the segment of the base and the segment to find the height. What angle do we form? That's a right angle, right? All right, so that gets us to finding the area of a triangle with the formula. The area of a triangle is half the product of the length of its base and its height, because this is half of a rectangle. Find the area of each triangle. So here we're given a base of 20 and a height of 8. So we have the formula, 1/2 the base times the height. We're going to substitute the known dimensions and solve the equation. Half of 20 times 8. Well, half of 20 is 10, and 10 times 8 is 80. Simple as that. Okay, so let's look at B on page 381. So here we're given the dimensions 5 and 12. The height is 5, the base is 12. So use the formula, 1/2 the product of the base and the height. 1/2 12 times 5. Now, do I have to multiply 12 and 5 first? No, I can take 1/2 of 12 and then multiply by 5. I could multiply 12 and 5 and then take half of it. However you're most comfortable with, okay? I like to make one of the larger numbers smaller, just to make the math fact smaller. So half of 12 is 6, and 6 times 5 is 30. And number 3. All right, so we have to find the area of this triangle. Okay, let's start with the formula. And do we know any of the dimensions? Yeah. They gave us a base of 8.5, and they gave us a height of 14. Well, now I don't really want to take half of 8.5, so I'm going to go ahead and use commutative property. I'm going to switch those numbers around. Okay, now I'm going to take half of 14, which gives me 7 times 8.5. So just multiply that. We'd wind up with 59.5 inches squared, or you could say 59.5 inches squared. All right, example 2. Problem solving using area of triangles. So you can use the formula for the area of a triangle to solve real world problems. So look at this. Each triangular face of the Pyramid of Peace in Kazakhstan is made up of 25 smaller equilateral triangles. These triangles have measurements as shown in the diagram. What is the area of one of the smaller equilateral triangles? So this building is made up of 25 of these smaller triangles. So we'd figure out the base is 12, the height is 10 and 4/10 meter. Plug those or substitute those into the formula. We'd have half of 12 times 10 and 4/10. Half of 12 is 6, and 6 times 10 and 4/10 gives us 62 and 4/10. So the area of one of the small equilateral triangles is 62 and 4/10 meters squared. Okay, so keep that in mind as we look at page 382. So, what is the total area of one face of the pyramid? So, what is the area of one face of the pyramid? So, we know that there are 25 equilateral triangles that make up the face. So, we can simply go 25 times 62 and 4/10, because the area of one triangle is 62 and 4/10 meters squared, but we have 25 of them. Okay. So 62 and 4/10 times 25. I come up with 1,560 square meters for one face. Now, what's the total surface area of the faces of the pyramid, not counting the bottom? And it's telling us here the bottom of a pyramid is a square. So how many faces do we have? We have to have 4, right? So it's going to be 4 times 1,560. So 1,560 times 4. And we come up with 6,240 meters squared. So again, what did we do? We knew that there was 25 smaller equilateral triangles on every face of the pyramid. We know that the area of one triangle is 62 and 4/10. So we have to multiply that area by 25 to figure out the area of one face or one side of the pyramid, right? So that gives us 1560 for one side, but there's 4 sides in a pyramid because the base is a square. So 6,240 meters squared. Now, number 5. Amy needs to order a shade for a triangular shaped window that has a base of 6 feet and a height of 4 feet. What is the area of the shade? Well, we could draw a picture to show this. We have a base of 6, and we have a height of 4 feet. All right, well, formula for a triangle, 1/2, base times the height. So 1/2, 6 times 4. So 3 times 4, 12. 12 square feet. All right, now we're just going to practice finding the area of various triangles. All right, so in number 1, they give us the formula. The formula for triangle will always be the same. The base in this one is 14, and the height is 8. Well, half of 14 is 7, and 7 times 8 is 56. So 56 inches squared. Number 2, so we have this pennant here, and it's in the shape of a triangle, and it has a base of 12 inches me say 12 inches, and it has a height of 30 inches. Well, we'll just substitute those into the formula. So half of 12 times 30, 6 times 30 is 180. Okay, so where did I get the 6 from? I took half of 12. Half of 12 is 6, and then we have to multiply by 30. Number 3. How do you find the area of a triangle? Well, all right, so what we've been doing, we start with the formula, we substitute the known dimensions, and then we solve the equation. That'll give us the area of the triangle. All right, 383. Again, we're just going to have some more practice finding the area of triangles. So start with formula, 1/2 base times height, substitute the known values or known dimensions. The base is 15, the height 10. In this case, this is one where I would wait to take the half, because 15 times 10, that's easy. That's 15 tens, that's 150. Okay, so what's half of 150? 75. So 75 centimeters squared. Number 5. Area equals 1/2 base times the height. Substitute your dimensions. We're going to take half of 24 times 20. I'm going to take half of 20. So I'm going to use commutative property of multiplication to switch the 20 and the 24. Half of 20 is 10, so 10 times 24. Now it might make more sense as to why I did that. Anything times 10 is really easy. All we basically do is put a 0 on the end. 24 tens is 240 feet squared. Okay. All right, number 6. So area equals 1/2 the base times the height. The base on this one is 12, and its height is 17. So half of 12 is 6. We just need to finish multiplying. 6 times 17. We get 102 inches squared. Number 7, again, that's a triangle. Area equals 1/2 the base times the height. The base in this case is 18, and its height is 32. Well, I want to go ahead and keep it in this order because multiplying a single digit by a 2-digit number is easier than multiplying two double digit problems or numbers. So half of 18 is 9. And now I have to finish multiplying by 32. So we get 288 feet squared. Number 8, what is the area of a triangle that has a base of 15 1/4 inches and a height of 18 inches? Okay. So what they give us? They gave us 15 and 1/4 for the base, and they gave us a height of 18. Well, I clearly want to take half of 18 as opposed to 15 1/4. So I'm going to rearrange those using the commutative property of multiplication. And half of 18 is 9. So 9 times. Now 15 1/4, that's the same as 15.25, right? 1/4, that's fourth of a dollar. A dollar is 20. A quarter is 25 cents of a dollar because it takes 4 quarters to equal a dollar. So 15.25 times 9. So we'd get 137.25 or 137 25 hundredths square inches. Or we can go ahead and rewrite it as a fraction. And 25 hundredths is the same as 1/4. So either way is correct. Number 9. A right triangle has legs that are 11 inches and 13 inches long. What is the area of the triangle? So again, we're going to start with the formula of area equals base times height. It really doesn't matter which one we call the height and which one's the base. So just substitute those numbers. So we get area equals half of 11 times 13. Now, neither one of those numbers are what we'd consider nice numbers, right? So half of 11. Well, that's 5 1/2, right? Half plus a half is 1, and 5 plus 5 is 10. 10 plus 1 is 11. So this is area equals 5 1/2 times 13. We'll go ahead and multiply that. And we get 71 5/10 inches squared, or 71 1/2 inches squared. Number 10. A triangular plot of land has the dimensions shown in the diagram. Okay, so here's our diagram. This is our plot of land. We want to know what is the area. Well, to find the area of a triangle, we use the formula area equals 1/2 the base times the height. In this case, the base is 30 and the height is 20. I'm going to rearrange those because I want to take half of 20 because I want to multiply by 10. I don't want to multiply this by 15. It could, right? It's not that difficult. 15 times 2 tens. I guess it's basically the same. Half of 20 is 10, and 10 times 30. So 30 tens is 300. So 300 square kilometers. Number 11. The front part of a tent has the dimensions shown in the diagram. What is the area of this part of the tent? First thing we're going to do, always write the formula. Then substitute the dimensions. Well, half of 8 is 4. And 4 times 5 is 20. So the area of that front face of the tent is 20 square feet. Number 12. This is a multi-step problem. And it says the 6th grade art students are making a mosaic using tiles in the shape of right triangles. The two sides that meet to form a right angle are 3 centimeters and 5 centimeters long. So the sides that meet to form the right angle are 3 and 5. It really doesn't matter which one you put 5 and which one's the 3, just that they form a right angle. And that there's going to be 200 of those. So let's find the area of 1. So 1/2 3 times 5. Well, this time I'm just going to go ahead and multiply 3 times 5. Because I can take half of 15, right? Half of 15 is 7.5. All right, so 7.5 centimeters squared each tile. And we have to multiply that by 200. So we have an area of 1,500 square centimeters. This one would, some of you might look at this and say, 7.5, why don't I just double that and put 2 zeros on it? Yeah, that would have been the easy way to do it. Okay. Because basically we're saying 7.5 times 2 hundredths. So 7.5 times 2 hundredths is 15 hundredths. 13. Monica has a triangular piece of fabric. The height of the triangle is 15 inches and the triangle's base is 6 inches. Monica says the area of the fabric is 90 inches squared. All right, so let's see here. Just something like this, a base of 6 and a height of 15. Okay, we're substituting the dimensions. Half of 6 is 3. 3 times 15 is 45. Oh, hers is twice as big as ours. So what did she forget to do? She didn't do the half part. Okay. She didn't multiply by 1/2. All right, 14. All right, so Wayne is going to paint the side of the house shown in the diagram. What is the area that will be painted? And explain how you found your answer. Well, we have 2 different shapes here, right? We have a rectangle and we have the triangle up on top. So we need to find area of the triangle plus the rectangle. Okay. That'll give us the total area. We're going to use area equals base times height for the triangle, 1/2 the base times the height. And for the rectangle, we're going to use base times height. What is the base? The base is 25, and the height of the rectangle is 12. Okay, the area of the triangle, 1/2. You notice that the base of the bottom of the house matches the roof line base. So the base of the triangle is 25, but the height of the roof line is 8. So we're going to take 1/2 of 25 times 8. All right, 25 times 12. That's 300. Okay. So the rectangle is 300 square feet. And the triangle, well, 8 times 25, that's 200, right? Because basically we're saying we have 8 quarters. That's how I'm seeing it in my head. 8 quarters. Well, 4 quarters equals $1. 4 more quarters would equal $2, so $2. So 8 times 25 is 200. I need to take half of that. So the area of the triangle is 100 square feet. Add those together, we get an area of 400 square feet. All right, so how did we get 400 square feet? We found the area of the triangle, which was 1/2, 25 times 8, and that gave us 100 square feet. And then we found the area of the rectangle, which was 25 times 12, which gave us 300 square feet. Then we just added them together. 100 plus 300 gives us 400 square feet. All right, number 15. Explain how the areas of a triangle and a parallelogram with the same base and height are related. Well, okay, so remember we started this lesson with drawing a rectangle? That's a terrible rectangle, by the way. I can do a better job than that. Sorry. All right, so we started with a rectangle, and when we drew a diagonal, right? Well, the base of the rectangle is the same as the base of the triangle. The height of the triangle is the same as the width or the height of the parallelogram. So, what can we say? We can say you can draw a diagonal in the parallelogram. That's going to form two congruent triangles. With the same base. The triangles have the same base and height as the parallelogram. So the area of the triangle is half the area of the parallelogram. All right, 16. A rectangle and a triangle have the same area. If their bases are the same lengths, how do their heights compare? Well, the area of the triangle, that would mean the height would have to be twice the base. Okay, so the height of the triangle Okay, so this is what I have so far. The height of a triangle is twice the height of the rectangle. has a height of 4, and the triangle has a height of 8. Okay, why is that? Well, remember, in the let's go through the whole thing. The height of the triangle is going to be twice the height of the rectangle if they have the same area and their bases are the same. So the only difference between the formula in a triangle and a parallelogram is that in a triangle you have to take half, right? Well, if the bases are the same, the only way to have them be equal is to double the height of the triangle. And the example would be if let's say they both have an area of 40 inches squared and they have a base of 10. Well, the base of the rectangle would be, the height of the rectangle would be 10 times 4, right? But if I had a height of 10 times 4 for the triangle, then half the product of 10 times 4 would give me 20, not 40. So I have to double the height. So 8 times 10 is 80, and then when I take half of 80, that gives me 40. All right, 17a. If the triangle has two sides that are the same length, what are the length of these sides? Right, so here we say as a right triangle has an area of 18 square inches. So we know, again, area equals 1/2 the base times the height. This time they gave us the area. So that the triangle has two sides that are the same length. What are the length of these sides? So basically, half the product of what would give me 18? 36, right? So 18 equals 1/2 of 36. So which two numbers multiplied together give me 36? 6 and 6. So our formula has to be 18 equals 1/2 6 times 6. How did we know that? Again, 18 equals half the base times the height. Well, the 18 is a result of taking the half of something. So isn't that the same as doubling the 18 then? And 18 times 2 is 36. But that's the result, that's the product of the base and the height is 36. And they told us in the question that the sides have the same length. Well, there's only two numbers that when multiplied together give us 36. 6. All right, B. What if the triangle has sides with 3 different lengths? What are all the possible whole number lengths for the sides that meet at a right angle? Well, basically, in this case, we want the factors of 36, right? Because we already know the base times the height has to be 36. But we want different numbers. So sides has to have 3 different lengths. So 1 times 36 would work. Because half of, if I multiply 36 and 1, and then take half of that, that would be 18. I could have 2 and 18. So all I'm doing is writing the factors of 36. Because I know if I plug these numbers in as the base and the height, and I take half of it, it's going to be 18. Because half of 36 is 18. All right. I also know 3 is a factor of 36. Since I know 3 and 2 work, 6 also works, but 6 is not, wouldn't result in different lengths. So it can't be 6 and 6. So, but I do know that 4 and 9 also work. So, what are the lengths of the sides that meet at a right angle? Again, like this, right? What are the sides of the triangle? The possibilities. I could have 1 and 36. I could have 2 and 18. I could have 3 and 12. Or I could have 4 and 9. Right. So that's it for finding the area of triangles. So until our next lesson, I will see you soon.